So basically, Norton theorem is similar to the Thevenin theorem. If you know the steps of Thevenin theorem, then you'll be able to understood the Norton's theorem. We'll do it by the comparison. Step number 1. Tell me what was the step number 1 we have done in the Thevenin theorem? First step is find out the value of load resistance. Remember, I told you that in whichever branch we need to calculate current, that was our load resistance, right? Like suppose if this is 4, 6, 10, 8, and they ask you calculate current in 8 ohm by using Norton theorem. So RL is 8 equal to 8 ohm, right? Next is step number 2. What was the step number 2? The Thevenin theorem, tell me. We need to remove RL, open circuit RL, right? But in the Norton theorem, we need to short circuit RL. Got it? Short circuit RL means just remove the RL and place a plain wire across it. That would be plain wire is like this. This is 4, this is 6, 2, 10, and just always as I told you, mark A and B across RL. Clear? In the Thevenin, like you have to remember by the comparison only, in the Thevenin you need to open circuit RL and in the Norton you need to short circuit RL. Okay. Now what was the next step number 3 in the Thevenin theorem? To calculate Thevenin voltage. But in this case we need to calculate Norton's current. Okay. We need to calculate Norton's current. Norton current is denoted by IN, or we can denote it by ISC. ISC means the short circuit current. Okay, so I am redrawing the diagram. This one is 4, 6. This one was short circuit, right? Now that's totally up to you. If you want to nodal analysis, you can use nodal analysis for the calculation of current. And if you want to do mesh analysis, you can do mesh analysis for the current. Okay. Suppose in this I'm using mesh analysis. This one is I1 and this one is IN. Now tell me the first mesh equation and the second mesh equation. I1 minus IN. IN I have taken up because this is IN. We need to calculate IN. Then, yeah, tell me the second mesh equation. Minus 6 IN minus I1 is equal to minus 2 IN minus 6. Now you can solve the two variable equation I1 and I1, IN, right? Then after solving you will get the value for IN. Next step, what was the step number 4 in the Thevenin? This we need to calculate Norton's resistance. Okay, Norton's resistance is denoted by Rn. So we need to follow the same procedure, that voltage source must be short circuit, okay, and current source must be open circuit, and RL must be open circuit. Okay, clear? Now in this case voltage source must be short circuit, so the diagram would be like this. This one is A 4 6 and right, So now you know 4 and 6 are connected in parallel. 4 parallel 6 plus 2, that is Rn. Okay, clear? Now next and the last and the final step, calculate current. We calculated Norton current, so we mark IN. Calculated Norton resistance, so we mark RN, and then connected back RL. Okay, this we need to calculate current. So formula for that would be I is equal to IN to RN divided by RN plus RL, right? IN we already know, RN we already calculated, RL we already know, 8 ohm. We just substitute the value and then we will get the value for the current. Understood? Formula will get it by using the current division rule. I think I didn't tell you about the current division rule. I'll tell you. First write down the formula. Okay?